14 seconds to compile after every save, 3 to 5 seconds for autocomplete. A single tRPC router with 180 procedures was forcing TypeScript to reinfer 45,000 lines of type definitions on every change. Here's exactly why. The article uses at tRPC/tanstack React query, which requires at tanstack/React query v5. If your project uses React query v4, install at tRPC/React query instead. Also, use action state is available in React 19. For earlier versions, use useForm state from React DOM. The article mentions splitting routers, but doesn't show lazy loading. Use tRouter with dynamic imports to defer type resolution and reduce compilation time. This is especially beneficial for large routers. The in-memory rate-limiting middleware shown does not work across serverless instances. In production, use a distributed store like Redis or a database-based rate limiter to ensure accurate counting across all instances. Let's break down tRPC v11 plus Next.js 16, complete setup and best practices, how it works, and the exact mistake behind that failure. tRPC is a TypeScript-native RPC framework that lets you build fully type-safe APIs without code generation or schema definitions. Instead of defining REST endpoints or GraphQL schemas, you write backend procedures as regular TypeScript functions, and the client imports them directly, getting full type inference from server to client with zero boilerplate. tRPC v11 uses a split package structure. The setup requires 4 files: the root router, the tRPC context, the client provider, and the API route handler. The app router integration differs from Pages router in one critical way. Server components can call procedures directly via a server-side caller, bypassing HTTP entirely. Here's the context setup. We initialize tRPC with a context type that includes Supabase client and userid. We export reusable building blocks, create tRPC router, public procedure, and protected procedure. The protected procedure middleware checks for authentication and throws an unauthorized error if missing. The API route handler uses fetchRequestHandler from at tRPC/server/adapters/fetch. It creates the context for each request by getting the authenticated user from Supabase. This handler is exported for both GET and POST methods. The root router merges subrouters by domain. This is where you split your router to avoid the 14-second compilation problem. Each subrouter should have at most 20 procedures to keep compile time under 3 seconds. The client is created with create tRPC React and the app router type. The provider sets up React query with a stale time of 1 minute and uses HTTP batch link to batch requests. Wrap your layout with this provider to enable tRPC hooks. Procedures are the API surface. Each procedure has an input schema, output schema, and resolver. Queries are for read operations and are cached by React query. Mutations are for write operations and trigger cache invalidation. Input validation uses ZOD schemas that serve 3 purposes: runtime validation, type inference, and documentation. Here's the user router with 4 procedures: me, list, update profile, and get by id. Notice how input validation uses ZOD schemas with defaults and constraints. The output schema for list ensures the client gets exactly the shape it expects. Mutations like update profile filter out undefined values before updating. Server components can call tRPC procedures directly via a server-side caller, bypassing HTTP entirely. This means no network round trip, no serialization overhead, and no React query cache involvement. The caller runs the procedure's resolver directly with the same context and middleware as an HTTP request. The server caller is created with create caller from the app router. It takes the same context as an HTTP request. In a server component, we call procedures directly, no HTTP, no serialization. If the user is not authenticated, the protected procedure throws an error and we redirect to login. Client-side hooks are powered by React query. UseQuery fetches and caches data, serving it from cache instantly, while a background refetch checks for updates. UseMutation triggers writes and invalidates related queries. Optimistic updates make the UI feel instant by updating the cache before the server responds. Here's how to use useQuery and use Mutation. useQuery fetches data with options like stale time and retry. useMutation calls update profile and invalidates the me query on success to refresh the cache. The utils object provides type-safe cache access. tRPC uses tRPC error for structured error handling. Each error has a code like unauthorized, not found, or bad request. The error formatter on the server controls what information is sent to the client. Never expose stack traces or internal details in production. The error formatter includes ZOD validation errors as field-level errors. On the client, we check the error code to display user-friendly messages. For bad request, we can show field-level errors from the ZOD schema. Middleware wraps procedures with cross-cutting concerns. You can stack multiple middleware on a single procedure. The order matters. Middleware runs in the order it is applied. Use middleware to narrow context types. For example, protected procedure guarantees userid is a non-null string. Here's a rate-limiting middleware using an in-memory map. In production, use upstash readies for serverless compatibility. Middleware is composed into procedure variants like admin action procedure, which stacks auth, rate limit, and logging. Server actions provide a simple way to call tRPC procedures without HTTP for form submissions. They run on the server, have full access to the tRPC context, and can be called directly from forms with progressive enhancement. Use revalidate path after mutations to update cached pages. The server action calls tRPC via createCaller, then revalidates the dashboard path. The client form uses useActionState for pending state and error handling. This pattern works with progressive enhancement. The form works even without JavaScript. This is the same issue we highlighted at the start. Here's exactly why that 14-second compilation happened. A team had 180 procedures in a single router. tRPC's type inference is recursive and deep. Every procedure, its input schema, and output type are resolved at compile time. With nested routers and generics, the complexity becomes O and 2, causing 14-second builds. A single tRPC router with 180 procedures forced TypeScript to reinfer 45,000 lines of type definitions on every file change, causing 14-second compilation and 35-second autocomplete lag. The fix is to split the monolithic router into domain-specific subrouters, each with at most 20 procedures. Use lazy loading for subrouters to defer type resolution until the module is actually imported. This drops compile time from 14 seconds to under 3 seconds. This is the mistake that caused the 14-second compilation, all 180 procedures in one router. The fix is to split into subrouters with at most 20 procedures each and lazy load them. If you omit the output schema, the client infers the return type as any, losing all type safety. Always define an output schema to validate the resolver's return value and provide type safety to the client. After a mutation, you must invalidate related queries to show fresh data. Without invalidation, the UI continues to display stale data from the cache. Always call utils, some query, invalidate, in onSuccess. To diagnose compilation issues, use nextbuild debug to see compile times. Profile TypeScript with TSC generate trace to identify slow types. Check your router size by logging the number of procedures. Then split and lazy load subrouters. Let's run through some common interview questions. What is tRPC and how does it achieve end-to-end type safety? tRPC infers types from server procedures, eliminating cogent and manual type definitions. How does tRPC handle input validation? Uses ZOD schemas that provide runtime validation, type inference, and documentation. What is the difference between server caller and client hooks? Server caller runs procedures directly without HTTP. Client hooks use React Query for caching and background refetch. And a few frequently asked questions. Can I use tRPC with REST clients? Yes, tRPC can be called via HTTP post with JSON, but the type safety is lost. Does tRPC work with server components? Yes, via createCaller for direct procedure calls without HTTP. How do I handle file uploads with tRPC? Use a separate root handler for multi-part uploads, as tRPC is JSON only. Let's recap the key takeaways. Split routers by domain, keep less or equal to 20 procedures each. Use lazy loading for subrouters. Always invalidate cache after mutations. Use server caller for SSR, client hooks for interactivity. Ready to go deeper? Up next, how to build an AI agent with Next.js, LangChain, and Supabase, then Next.js 16 caching strategies explained, the 2026 guide, then Prisma ORM best practices with Next.js 16 in 2026, and server actions versus tRPC in 2026, when to use which. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.